Okay, in this example we have a hopper that's near a wall, and we want to attach the hopper to the wall, or maybe we have a pipe coming from the wall or through the wall into the hopper to feed the hopper with sand or something. So we want to know the shortest distance from the back panel of this hopper to the wall. So we're going to use two-dimensional views and projections to do that. So let's go to our layout view. I've already set up an 11 by 17 ANSI B size piece of paper. And we'll set up the front view, top view, and side view here. Put them a little closer together. In fact, I'm gonna want to measure in both the top and the front view. So I want to keep the distance between them pretty equal. So let's just put 1 inch between views here. So I'll draw a nice little reference line here. Move it over a little. Maybe I want that above the, let's go another inch. Okay, so 2 inches between the reference line and the top of the hopper anyway. I'm not too concerned with the wall right now. So I'm going to put that same 2 inches in the top view. Okay, so now the hopper is 2 inches away from the reference line here and 2 inches away from the reference line here. The optical illusion tells me, oh, that's 1.5 inches. It's not an optical illusion. Let's move this down 1/2 inch then. Okay, now there's equal spacing between the hopper and the reference line in both the views. Kind of want to do the same thing. So let's go 2 inches over. That'll work. Nice long reference line. Okay, 2 inches. Okay, so the hopper's 2 inches away in all views from the reference lines. So now, make those cross. Need to place a point, so let me set up my P-type, which I think I already have it at 1/8 of an inch in absolute size, and it has a nice little style to it that I can use. So I'll just put the point, let's say I want it on the wall back in this view. Let me use construction lines for these. Okay, and since we know it's against the wall, I'll draw that point in the top view, and hopefully the side view. That was weird. Okay. So now I have the point in all 3 views. And now I want to find the distance, the shortest distance here. Well, as it turns out, I have the front edge of the hopper parallel to both the front and the top view, so I have that line as a true length line, which makes it a point in the right side view, as well as the back line, which are coincident in the front view and closest to the wall in the top view. So and I have the same thing for the bottom of the hopper. So basically this edge, this back edge is in true length. So really, I can just draw that line perpendicular to the back side of the hopper, and that is the shortest distance between that point and the hopper. That was easy, but I also want to find out where that point is on the face of that, on the back face of that hopper. So I'm going to produce an auxiliary view using the full section tool. Produce that view over here. Stretch it out a little bit, extension, so I can see the hopper a little bit. Give an extension snap. There we go. Something like that. Okay, so there's the hopper, and so now I see the hopper and the back face of that hopper nearest to the wall in its true shape. I can project. Just use this line. Well, I don't really want to use that line. Extension. So I can project that line through, but how far is it along this edge? Well, that just makes me need to measure that distance. So the distance that this point is from the reference line should be the same as the reference line from the reference line between, but I don't really have a reference line. I mean, it is projected straight from this. I mean, it's parallel to that, but where's the reference line? I kind of need to fabricate that. So another circle is needed, and I need to measure that distance. So if I treat this section line as my reference plane, I can measure the distance between that and the top corner of the hopper and find out where that is from the top corner of the hopper here, and I can just move my, let's redo that circle in a minute. Let's make it a little bit smaller. So now I just need to move that reference line. So now that's wherever this is, wherever this projected view is, it now forces this reference line to be where it is. So it's a little bit backwards, but so that one not needed. And now the point is this distance, the radius of this circle from the reference line, which means I can just project that straight to the where it is in the against its reference line, which is going to be this line right here. So there's where that point, where the intersection needs to be, where we constructed that intersection. There's my point. So I could go back to my model space and take a measurement of how far it is in its true length from the edge of, I can change my user coordinate system and place that point on the back face of that hopper precisely.